Session 31 will discuss about degrees of freedom and equipartition of energy. So to know the in this session we have to know what is meant by degrees of freedom and what is the monoatomic gas, diatomic gas and triatomic gas we have to learn, and we have to learn the principle of equipartition of energy also. So to know this, we after this session will know all these things, and we have to know what is degrees of freedom, types of gas, equipartition of energy, or degrees of freedom. The least number of mutually independent coordinates required to define the state of the system is called as its number of degrees of freedom. So in the field of different contests and degrees of freedom are calculated differently. Degrees of freedom in physics and chemical kinematics is used to specify the number of independent ways in which an atom or a molecule can take up energy. In any type of motion that contribute a quadratic term in some generalized coordinate to the internal energy is called as degrees of freedom. Now, degrees of freedom generally is represented F is equal to degrees of freedom is equal to 3n by R, where n is called as number of molecules present in a gas, where R is called as it is a independent variables of that gas. For example, for our monatomic gas, F is equal to 3 into 1 minus 0 is equal to 3. So degrees of freedom for monatomic gas is 3, where n is called as 1 atom will be there. For diatomic gas, F is equal to 3 into 2 minus 1. 3 2 is 6, 6 minus 1 is 5. So degrees of freedom will be 5 will be there for a diatomic gas. For a triatomic gas, there is a two types of triatomic gas will be there. Linear molecule and non-linear molecule. For linear molecule, 7 degrees of freedom will be there. For a non-linear molecule, there is only 6 degrees of freedom will be there. Now, this principle of equipartition of energy. The energy of a system in a thermal equilibrium is shared equally among all its energetical accessible degrees of freedom, and the energy is associated with each quadratic degree of freedom is of kT. This is a statement of principle of equipartition of energy. What is the significance of this means? The equipartition theorem predicts not only that the available energy will be shared evenly among the accessible mode of motion, but it is also makes qualitatively predictions about how much energy will be appear in each degree of freedom. By spreading out the total energy available in the system equally amongst all the accessible modes of the motion, the system will generally try to maximize its entropy. This is the significance of the principle of equipartition of energy. How to derive this equipartition of energy means, according to kinetic theory of gases, the mean kinetic energy of a gas molecules at a temperature T is given as half mc square is equal to 3 by 2 kT. For example, a molecule is moving with a velocity c in a cube. It is moving u velocity along x-axis, v velocity along y-axis, and w along z-axis. Therefore, c square is equal to u square plus v square plus w square. As it is move along x-axis, y-axis all are equivalent. The mean square velocities along the three axes are equal. Hence, u square is equal to v square plus w square. Hence, u square is equal to v square plus w square is equal to 1 by 3 into c square. Therefore, half into mu square is equal to half into mv square is equal to half into mw square. All are equal. Therefore, half mc square is equal to 3 into 1 by 2 mu square is equal to 3 into half into mv square is equal to 3 into half into mw square. We know that half mv square is equal to half mc square is equal to 3 by 2 kT. Therefore, half mu square is equal to half mv square is equal to half mw square is equal to half kT. Hence, the average kinetic energy associated with each degree of freedom is of kT. Then, this is the summary of this session. So, we learned about degree of freedom of a gas is how much, and how equipartition of energy will be there, how average kinetic energy associated with each degrees of freedom. Now, the average kinetic energy associated with each degree of freedom is of kT. The expression for degrees of freedom for a system is F is equal to 3n minus 2. Then, what is the degree of freedom? It is called as total variables in the process. How many degrees of freedom do for a non-linear triatomic gas molecules? It is 6. Oxygen is a dash molecule and has a dash translational degrees of freedom. It is a diatomic molecule. It has a 3 degrees of translational degrees of freedom. So, thank you.